Okay guys, so today we need to review the law of sines. We have that quiz tomorrow, remember? I think we should first talk about what it is, and then how and when to use it.
Yeah, that's good idea. I always get confused where I should use the law of cosine and the law of sine. So let's clear it too.
Alright, so the law of sines is used when we have either an ASA or the angle side angle, or AAS or the angle side triangle. Also when it's an SSA or the side side angle case, but that can be tricky sometimes.
Exactly. Basically, when we know enough the angles and sides in a triangle, but not all three sides or triangles yet. So the law of sines relates to the sides and their opposite angles. Let's say that A over sin A equals to B over sin B is equal to C over sin C, where A, B, and C are the side and lengths, and the A, B, C, which is the capitals, are the opposite angles.
Yes, and the important thing is the ratio. Side over sine of the opposite angle, it's consistent across the whole triangle.
Hold on, let's talk about the basic first. So why do we even need the law of sines?
Good questions. We need it because sometimes when solving triangles, you don't have a right angle. So you can just use the basic Sohcahtoa or Pythagoras. The law of sine helps us when the triangle is oblique, meaning not right angle.
Exactly, and it lets us find unknown sides or unknown angles easily using what we already know.
So let's try a small example. So it sticks. Suppose we have a triangle with A is equal to 40 degrees, B is equal to 60 degrees, and the side A is equal to 8 cm. We're supposed to find the side B.
Alright, first, according to the law of sine, A over sine A is equal to B over sine B. So substituting the values, 8 over sine of 40 degrees is equal to B over sine of 60 degrees. Now cross multiplying, B is equal to 8 times the sine of 60 degrees over the sine of 40 degrees. Then we just use the calculator.
Yes, let me compute that. So sine 60 degrees is about 0.8660 and sine 40 degrees is about 6428. Multiplying 8 times 0.8660 is equal to 6.928.
Nice! See, it wasn't too bad. So that steps are set up the proportion using sides and opposite angles, substitute known values, cross multiply to solve for the unknown, use the calculator carefully for sign and division.
Yeah, but what about solving for angles? Like if we know two sides and one angle.
That's where we use the inverse function. Suppose we have A is equal to 7, side B is equal to 10, and an angle A is equal to 30 degrees. We want to find the angle B. So first, we have the A over sin A, and B is equal to B or over sin B. We need to substitute the 7 over sin of 30 degrees and 10 of sin B. Since sin 30 degrees is 0.5 over sin B.
Great, but don't forget, always check if your calculator is in degree mode. Otherwise, your answer will be wrong.
Exactly. One time mine was in radians and I couldn't figure out why my answer was weird.
Same. So, okay, when we solve for angles, either getting the sine B value, after getting the sine B value, we shift or second then sine button to use the inverse sine function.
Exactly. Also, let's not forget something important. In SSA cases, sometimes there could be two triangles possible, one triangle or even no triangle. It's called the ambiguous case.
Yeah, that's one tricky part of the law of sines.
Quick review. If A is less than B and A is less than b times sine of a, no triangle. If a is equal to b times sine of a, one right triangle. If a is less than b, one triangle. If b times the sine of a, that's less than less than b, two triangles.
Maybe we should do a sample of the ambiguous case to see it.
Sure. Suppose A is equal to 7b, B is equal to 10, and A is equal to 30 degrees. First, compute B multiplied by sine A to 10 multiplied by sine 30 degrees is equal to 10 multiplied 0.5 is equal to 5. Now, compare A to B multiplied by sine A. 7 is greater than 5, so a triangle exists. Also, since A is less than B and A is greater than B, multiply sine A, two triangles are possible.
Which means two different possible angles for B.
Right. After finding one value for b, the other possibility is about 180 degrees.
And both can give valid triangles, provided the sum of angles is less than 180 degrees.
So it's a bit complicated when it's side-side angle, but otherwise, law of sine is friendly.
True. So to summarize everything, use law of sines when you have ASA or AAS or SSA triangles. Set up the proportion side over sine of its opposite angle. Solve for the missing side or missing angle. Use inverse sine to find angles. Watch out for the ambiguous case in SSA.
And double check that your calculator is in degree mode always.
Which also lists common mistakes students make, so we can avoid them. Number 1 is forgetting which sides of which angle. So also not cross multiplying properly. Also forgetting to press the inverse sign for finding the angles, and calculator is set in radians by mistake.
Nice list. Don't rush. Take time setting up proportions correctly. If the proportion setup is wrong, the whole answer is wrong.
Agreed. Before we end, let's do a final question. In a triangle, A is equal to 50 degrees. A is equal to 9 cm and B is equal to 12 cm. Find angle B.
Using A over sine A is equal to B over sine B, 9 over sine 50 degrees is equal to 12 over sine B. Sine 50 degrees is equal to 0.7660, so 9 over 7660 is equal to 11.75. So 11.75 is equal to 12 over sine B. Cross multiplied 11.75 multiplied by sine B is equal to 12. Divide sine B equal to 12 over 11.75 is equal to 1.0213.
Wait, that's more than 1. That means no triangle is possible with those given measures.
Exactly. Assign value that can be greater than 1. Therefore, no triangle can be formed.
Good catch. See? Understanding the law of sine help us notice impossible cases too.
Awesome discussion. I feel so much better about tomorrow's quiz.
Same. Let's ace it.
Nice!